All right, I calculated it out. I got a number of 3,600 moles. Okay, so that seems like quite a lot, but that's a mass. This is actually a quite large room. Most ceilings are only about 2 meters tall, so for 3 meters by 5 meters by 6 meters, it's a pretty sizable amount of space. So we can figure out exactly how much the mass of that is, and then make it even in more sense. My sense of numbers in terms of these types of things isn't the strongest, but that's certainly something we could figure out, and that's what our answer is. So if these are reasonable temperatures, yeah, it's a reasonable temperature, yeah, it's a reasonable pressure. Okay, it's a big room, but so sure, 3,600 moles. It doesn't seem completely unrealistic, I suppose. The second part of this question asks, if the temperature increases by 5 Kelvin and the pressure remains constant, how many moles of air leave the room? So we have a second case where the temperature is now equal. I'll just call this T2, or well, let's call it TB since this is question B. The new temperature is 305 Kelvin. It says that the pressure is still the same. It's 1 atmosphere. The volume of the room certainly is not changing, so that is still the same. That's actually 90, right? 6 meters times 5 meters times 3 meters, that's just 90 meters cubed. And it asked how many, the number of moles that left the room. So, well, we could just plug this right back in, right? The exact same equation we did this for, the same relationship. We're just solving for N, so that's PV equal over RT. P here again is 1.01 times 10 to the 5th pascals. The volume of the room is 90 meters cubed. The ideal gas law constant is 8.13 joules per mole Kelvin, and the temperature is 305. So obviously we're dividing. This is the exact same numerical value as we had up here, except this temperature is slightly larger in the denominator, which means we're going to have fewer moles. So the question asking how many moles of air leave the room, that makes sense because we're actually going to get a smaller number. So let me see if I can record this while actually doing this. I'm using my laptop to do the calculation, so chances are, since I'm trying to do it live, I will certainly screw it up, right? Okay, and I got 3,584 moles. So how many left? Looks like about 16. 16 moles of air left. Whoop, 16 moles left the room. That's quite a few moles of stuff, I would say, for only a 5 Kelvin difference in temperature. Although 5 Kelvin, that's the same difference in temperature as it would be in Celsius. It's like a difference of 5 degrees Celsius, which is quite a lot. That's quite a lot. That's in the neighborhood of about a 10 degree shift or a 9 degree shift in Fahrenheit scale. So going from 80 to 90 degrees or something like that, or from 90 to 80 degrees rather. So that's the answer. Seems pretty straightforward.